Good evening, math lovers, haters, those here because we want to pass the test. I imagine you're here because you're interested in learning about the special right triangles. Let's see what's so special about them. So diving right into it, we're going to take a look at the 45, 45, 90. What makes this one special is we have two legs that are exactly the same. These two legs are congruent, and then we have a hypotenuse. Now it helps at first to solve a simple triangle like this with given numbers. Easiest numbers to pick are 1, and this one has to be 1, 2, because we have congruent sides. Now, the Pythagorean theorem tells us that we should have leg squared plus leg squared equals hypotenuse squared. That's our c, that's the hypotenuse. So working this out gives us 2 equals c squared. And taking the square root of both sides, c equals root 2. If you want to solve problems dealing with special right triangles, this is not incredibly important, but it could help to understand where it comes from. This is what I like to call the base diagram for a 45, 45, 90. Now where the 45s are here and here. And we could also have the same diagram, but with the variables if we wanted to. We can make these into x's and still have it make sense. So we're going to go through I never like to say simple or hard, right? So that's all depending on how used to this stuff we are. But one of the more simpler problems you can get with the 45, 45, 90 triangle. One of the more straightforward ones. A straightforward problem with this might give you the lengths of one of the legs. They may put the 45s in here, they may not. They might put the tick marks here to show that those are congruent. So if this was a 7, this would also need to be 7, and then the hypotenuse, 7 root 2. And we do not need to use the Pythagorean theorem each time we solve this, because we have this diagram to look at. Look at how these diagrams compare. One is simply scaled up, so we could say the scale factor is something like 1 to 7. You may also see a diagram where they give you some information about the hypotenuse and ask to find the legs. Let's clear some space here. So let's say that they tell us that this hypotenuse is 8 root 2. So we can kind of work backwards, and comparing it to this diagram, you can see that 8 is like x. So therefore, we should have an 8 here and an 8 here. Those are some of the more straightforward examples. The way they make these more difficult is to reorient the triangle in a different direction. That's one way that textbooks teachers try to confuse us. Little point about the confusion. Sometimes we wonder, why are teachers trying to confuse us? It's not necessarily a nefarious thing, in other words, with bad intent. It's because life throws us a lot of different things that look different, so we have to know how to handle them. So we throw a 45, 45 triangle here that's a little rotated. I want to identify everything. So what if I made this, say, fractionally 1/2? Well, this leg would also be 1/2. This one looks a little bit longer right here, but remember, this is not necessarily drawn to scale. So the 1/2 again is still like our x. So we're going to do 1/2 times root 2. And of course, anything should be simplified as much as possible. We don't really want to leave it like that. You could say this is like over 1, and our final answer for the hypotenuse would be root 2 over 2. And for the really screwy examples, they'll put the root 2 where you don't expect it to be. This is important. What if I were to say that this was, on this side, 6 root 3, and we want to find the missing dimensions? Well, this will also be 6 root 3. That's also a leg. And then we would have to find this. This is where it helps to set up either equations or think about it in terms of words. In terms of words for this one, we could say perhaps the hypotenuse is the leg multiplied by root 2. So we're going to take one of the legs, 6 root 3, multiply it by root 2, and now we get 6 root 6. So we multiply root 2, multiply the numbers inside them. I actually intended for this problem to look slightly different, so let me go through the way that I wanted this to look. I actually wanted these to be root 2's because that's probably how they will try to confuse us. This is 6 root 2. Actually, let me start with really fresh numbers so we don't get any of these examples confused. Let's make this 13 root 2. This other leg would then have to be 13 root 2. And then based upon this relationship, we're supposed to take the leg and multiply that by an extra root 2. So this is the leg. Times root 2. And what happens when we multiply two with the same roots? Well, we just get the same number back. You could think about this as being 13 root 4, which is 13 times 2, or 13 times 2 right away. The root times that same root gives you just that number. So then this hypotenuse will be 26, and it doesn't contain any radical. So that could happen. That's for our 45, 45, 90 triangle.